Hello everyone. In our last session, we talked about inverse sine function and inverse cosine function. Now you all must be waiting for that do we have other inverse trigonometric functions also like inverse sine and inverse cosine? Yes, we do have. So in this session, we will be taking only other inverse trigonometric functions, definitions and their graphs. So let us start first with inverse tangent function. Don't get perturbed because of that name tangent. Tangent word is actually the name and we have been calling it as tan. So inverse tan function I define. And how do I define? Again, keeping that same thing in mind, that original function, the parent function has to be a bijective function and then only we will be defining its inverse. So tan function I pick up from minus pi by 2 to r, and what I mean is domain of tan function is minus pi by 2 to pi by 2 and codomain is r, and function happens to be bijective function. So basically codomain and range are going to be equal. From there I write tan inverse, and tan inverse would be defined as from r to minus pi by 2 and definition is x equal to tan inverse y if and only if y equal to tan x, exactly like in the previous cases of sine and cosine inverse function. Now your attention should be towards domain. So domain is r and codomain or range both are same and nothing but minus pi by 2. What is next thing we should observe? It is nothing but the graph. Okay, so we will try to draw the graph of y equal to tan inverse x, and graph looks like this. Now if you wish, you can just remember the graph, the shape, from where it starts, between which two lines the graph is seen. I mean, all such things you can see from the graph and try to remember, because every time you may not have time to do the exercise of drawing graph of y equal to tan x and then take its image, etc. Other one, I mean, the other type is that you actually go for graph of y equal to tan x, draw the line y equal to x and then take its reflection, and that reflection graph would be nothing but graph of y equal to tan inverse x. I am leaving this to you. I mean, some students are comfortable first with drawing graph of y equal to tan x and then taking its image. Or some are good in memorizing things and so they will pick up the first graph straight away as graph of y equal to tan inverse x. So choice is yours, that if you wish, you can take graph of y equal to tan inverse x as reflection of the graph of y equal to tan x in the line y equal to x, like in the previous cases. Now let us move to the next one. And the next one is inverse cosec function, means cosec inverse now we are going to define. Again we will be picking up correct cosec function. When I say correct, I mean the domain and codomain in such a way that function turns out to be a bijective function. And I picked up the domain as minus pi by 2 and I have removed that 0 from there. Why do I do so? Because sine function becomes 0 at x equal to 0. So x equal to 0 cannot be in the domain of cosec function. And its range I have taken, or codomain I have taken as minus infinity to minus 1, union 1 to infinity, and then only I can define inverse cosec function. And inverse cosec function, like before, we will be writing x equal to cosec inverse y if and only if y equal to cosec x. Now domain should take your attention, and domain is minus infinity to minus 1 union 1 to infinity. And what about codomain part? Codomain part is minus pi by 2 minus singleton set 0. That point you will have to remove. Now graph. Now how does graph of y equal to cosec inverse x look? The graph is something like this. You can see that it lies in the first and third quadrant. It doesn't pass through origin, but it is symmetric about the origin. I mean, any such points you can observe from the graph. And those who are uncomfortable with the graph directly, they are still free to do that previous exercise. They will be drawing graph of y equal to cosec x between actually minus pi by 2 to pi by 2 and then take its reflection in the line y equal to x, and then the dotted line curve I have shown for y equal to cosec x, and then its reflection I have shown as the bold one. You can see graph of y equal to cosec inverse x there, which is same as the previous one, the top one. With this, I move to the next one. And the next one is y equal to, now sec inverse I am going to define. So inverse sec function, for that correct domain and correct codomain you will have to choose. I have taken domain as 0 to pi and I have removed now singleton set pi by 2. Means that point x equal to pi by 2 I have removed from the domain. Why do we do so? Because cos x becomes 0 at x equal to pi by 2 and hence sec function will not remain defined there. So obviously we will have to remove that point. And now I am free to define sec inverse because I have made sure that in this interval 0 to pi minus pi by 2 function happens to be a bijective function. And from there I define inverse sec function as like before x equal to sec inverse y if and only if y equal to sec x. Domain you should remember and codomain you should remember. Codomain I mean range here. So range is 0 to pi minus pi by 2 and domain as I said before minus infinity minus 1 union 1 to infinity. Now immediate task is to draw the graph and graph of y equal to sec inverse x would look like something like this. Again, certain points you will have to remember. It does not pass through origin. Is it symmetric about origin? Is it symmetric about y-axis, etc. And then you can have your own important notes. Make sure you do that exercise. Take paper, pencil, draw the graph, write those important points. Unless you do that, you will not remember main things about inverse sec function. Same as with inverse cosec also or maybe inverse tan function also. And those who are uncomfortable with directly knowing the graph, they are still free to draw the graph of y equal to sec x first, then draw the line y equal to x, then take its reflection. That exercise you can always do. And hence, I have again mentioned there, you can draw the graph of y equal to sec x by drawing line y equal to x, drawing graph y equal to sec x, and then take its reflection. Reflection graph would stand for y equal to sec inverse x. Now, which is remaining? Now, that is nothing but cot inverse. So, we go for inverse cot function. Again, my exercise is to choose the correct domain and codomain. So, the correct domain what we choose is 0 to pi and then I have taken codomain as r. And I made sure that it is bijective function. So, I am free to use word codomain or range. The inverse function is defined as x equal to cot inverse y if and only if y equal to cot x, exactly like before. What should take your attention? The domain and range. So, let us remember, domain is set of real numbers, capital R, and codomain is 0 to pi. Now, what next? We have done this exercise now so many times. Now, it has to be graph of y equal to cot inverse x. Now, graph of y equal to cot inverse x looks like this. Remember, please. Now, this graph at some places I have observed is not given correctly, but this is the right graph which you can check yourself by drawing first graph of y equal to cot x in the interval 0 to pi. Draw the line y equal to x, then take its reflection and you can verify yourself that y graph of y equal to cot inverse x looks like this, the top one. Now, with this information, now we have gathered all we have done in the previous sessions, inverse sine and cosine function, and now in this session we did inverse tan, inverse sec, inverse cot, inverse cosec, everything we have done. With this background, we will be taking more and more and in inverse trigonometric functions. Mind you, please, this topic is extremely sensitive. You have to be alert all the time, and for that, all these things what we did in this session and in the previous session, they are important. So when we meet in next session, you will have to prepare everything. Please keep revising and then we will meet. Till then, stay tuned. Thank you.